Today we're going to talk about understanding exponents. Exponents is one of those algebraic things that are part of our order of operations. It's a multiplicative property, meaning multiplication, that is important for you to understand to truly have a grasp about what the value of numbers mean. We've talked a little bit about it, but now we're going to go into detail as to about what are exponents. Exponents are expressions that are made up of a base and an exponent. Those are the two important parts. Probably want to highlight that. They're written with the base being the big number and then the exponent being the smaller number. An example would be 3 to the 4th power. It reads 3 to the 4th power. There are special exponents like 3 to second powers and third powers, which read as squared and cubed. And you've had some experience with those when you're dealing with area and volume. So what does exponential expressions mean? Well, 3 to the 4th power, like I said, it's a multiplicative property that literally just means that it's this base multiplied by itself however many times the exponent is. So 3 to the 4th power is actually 3 times 3 times 3 times 3, which of course, I like to see, we know that multiplication is commutative and associative, so I can do it in the order that I wish. So 3 times 3 is 9. 3 times 3 is 9, 9 times 9. 3 to the 4th power has a value of 81. 3 times 3 times 3 times 3. The most common mistake that students make with dealing with exponents is that they take 3 to the 4th power and they do 3 times 4, and try to say that the value is 12. We know that this equation is not true. 3 to the 4th is not 3 times 4. Therefore, it is not 12. It's pretty simple and it's pretty straightforward, so I want you to try a couple things. It's your first round of try-its, and there's going to be a second round to come after these. I'd like you to try 4 to the 4th power. I'd like you to try 6 to the 3rd power. And then I'd like you to try 10 to the 4th power. I want you to pause the video now and do the try-its before we move on. Now that you've paused the video and you've done your try-its, I want you to pay particular attention to this last try-it, 10 to the 4th power. If you noticed, that's going to have the value of 10 times 10 times 10 times 10. Now, because I've ran out of room at the bottom, don't get confused because I'm going to work up instead. We know that 10 times 10 is 100. Again, multiplication is commutative and associative, so I can do it as I'd like to. I know that 10 times 10 is 100. That's cool. Now it's multiplying 100 times 100, which when you multiply, I like to tell students, just take these extra zeros and they automatically go into the answer. That's why when we do 2-digit by 2-digit or 3-digit by 3-digit, when we move through those base 10 places, we put place blockers in there. 100 times 100 ends up being 10,000. This is an important point moving forward. That's why it says, so what's next? I don't want you to know how to solve exponents simply so that we can complete PEMDAS. It's not that easy. What exponents allow us to do is enrich and enhance our understanding of what place value and what numbers truly mean. It gets truly important when we deal with science and we're talking about scientific notation. So this is part 2. Understanding exponents, a look at scientific notation. Well, what is scientific notation, you might ask? Scientific notation is just a way that scientists express really, really large numbers. When you're doing theoretical physics or when you're calculating populations of insects, these scientists come up with numbers that are just huge. To save space and save time, they learn to use scientific notation. The base 10 system makes it possible. But let's look at what we already know and how it relates to exponents. First of all, you know that 10 times 10 equals 100, which is 10 squared. You know that 10 times 10 times 10 is 1,000, which is equal to 10 to the 3rd power. Just like we talked about with the try-its, you know that 10 times 10 times 10 times 10 is 10,000, which is 10 to the 4th power. Have you seen the pattern yet? Go ahead and fill this out. 10 to the 5th power If you've seen the pattern, it's going to make it super easy. Now, we know that 10 to the 5th power means 10 times 10 times 10 times 10 times 10. Got it? Or, if you see the pattern, 10 to the 2nd power has 2 zeros. 10 to the 3rd power has bumped it over, so there's 3 zeros. 10 to the 4th power has bumped it over, so there's 4 zeros. 10 to the 5th power will have 5 zeros. Meaning 10 to the 2nd power is the hundreds, 10 to the 3rd power is the thousands, 10 to the 4th power is 10,000s, 10 to the 5th power is the 100,000ths. That means 10 to the 6th power, all together now, would be the millions. So how do we use it? We use it for numbers like this. This number right here is 3,142,000. That's a lot of cheddar, baby. But we don't want to have to write this number every single time. So we can express it as 3.142 times 10 to the 9th. Now, I know what you're saying. You're saying, whoa, Mr. Marriott, you just said that 10 to the 9th power would be a 1 with 9 zeros after it. I did, but that's the place value it would go to. 10 to the 9th power is 1 billion. It's 1 with 9 zeros. But if you take 1 billion and multiply it by 3.142, you're going to end up with 3,142,000. Don't believe me? Go ahead and try it. To give you a smaller example, we have 2.9 times 10 to the 4th power. Whoa, Marriott, you told me that 10 to the 4th power was going to be 10,000. I did. 10 to the 4th power is 10,000. But if you take 10,000 and you multiply it by 2.9, think about it. 10,000 times 2 is 20,000. 10,000 times 3, which 2.9 is close to 3, would be 30,000. 2.9 times 10,000 will be 29,000. Again, you can rewatch the videos and listen to the explanations and go through it step by step with me again if you need to. I want you to do some try-its now. It really, guys, is that simple. We just need to do some practice with it. So what I'd like you to do is I'd like you to rewrite these three numbers using scientific notation. 30,000, 6,400,000, 2,394,000. Remember, in each case, you're going to have a number times 10 to a certain power. I'm going to put in because I don't know which power, and it's going to be different in each case. Then what I'd like you to do is I would like you to rewrite these three numbers in standard form. This is really, scientific notation is a fourth form. We've talked about expanded form, we've talked about word form, we know standard form, now we have scientific notation. 9.7 times 10 to the 5th power, 3.21 times 10 to the 7th power, and then the really challenging one, 6.217 times 10 to the 12th power. Remember, that's 10 with 12 zeros after it. It's a huge number. It's trying it, guys. I just need you to take a risk. Try something. Come in tomorrow being able to show me the work you did with these try-its and what you were thinking, and we'll take it from there.